Hello everyone, this is Mrs. Lindsay. Today we're working on the Great Questions Related Rates worksheet, and this is problem number 1. Let's go ahead and dive into it. At a sand and gravel plant, sand is falling off a conveyor into a pile shaped as a cone at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet high? Alright, well we know it's a cone, so I'm going to go ahead and draw the cone. Oops. Let's go ahead and draw that cone. And I know I have a radius here. That's my radius. And this is my height. So again, hopefully this looks a little familiar from geometry from last year. So again, all I did was draw a cone there. So we know sand is falling off a conveyor belt at a rate of 10 cubic feet, so that's feet cubed per minute. Okay, so what is measured in cubic feet? Hopefully you're thinking volume. So that's dV over dt, which is our time here. The diameter, okay, diameter of the base of the cone is approximately 3 times the altitude. Well, altitude is the height. And the diameter, let's go ahead and write that out, is 3 times that. Okay. Well, what do we know about the diameter in terms of the radius? Because that's what we know over here as well. So the radius is twice the diameter. So if we plug in 2r for diameter, solve that for r, we get r to be 3 halves h, or 3 over 2h. Why do we need that? Well, if we think about the volume, this is one of the formulas I would actually give you, and we'll talk about the formulas more in class. But a third pi r squared h. That's volume of a cone. Okay, we have a lot of different variables going on in here, and so since we already have r equals 3 halves h, let's go ahead and plug that in. Let's simplify this formula a little bit before we take the derivative. So I'm going to plug in 3 over 2h squared, because that's radius squared. And let's go ahead and multiply here. So the volume equals 1/3 pi. So this is going to be 9 over 4. H squared times h would give me h cubed. And then again, let's simplify again. Before we take this derivative, a third times 9 over 4 would be 3 over 4 pi h cubed. Now we have something that's a little bit easier to take the derivative of because my leading coefficient is 3/4 pi. This is a number right here. Okay? So when I take the derivative of v is 1 times dv dt, again always with respect to time, this is a number, so I take 3 times 3/4 pi. Well, 3 times 3/4 pi is going to be 9/4 pi. H, decrease your exponent by 1, dh dt. Let's go ahead and pause there. Alright, now we're at our later point in time. Let me move this up just a little bit. What do we know it's later? Okay, we didn't finish, right? At a rate, at what rate is the height of the pile changing when the pile is 15 feet high? Again, that's later. That's when our height is 15 feet. So this is 15. We know our height is 15. How does that help us? Let's see if we need to find anything else out. Here's our formula here. We know h is 15. Let me go ahead and rewrite this up here so I don't have to keep moving that down. Pi h squared dh dt. So I have, again, h is 15. We know dv dt, so let's go ahead and plug that in as 10. h is going to be 15, then you square it, dh dt. And now, if I go ahead and solve this, go ahead and plug that in your calculator. All you're going to do is multiply this all together, divide, take 10 divided by that. You should actually get 0.006. And how is that measured? Well, this height is in feet, and our time is in minutes. Okay. Alright, and that concludes number 1 on the GREAT questions worksheet.